and welcome to the Open Systems Media eCast. Are continuous delivery practices possible when developing embedded systems? That's actually a very good question, and we will be answering that question over the next hour or so. My name is Rich Nass, and I'm the Brand Director for Embedded Computing Design, which is part of Open Systems Media, and I'll be your moderator today. You'll be hearing from two speakers today. The first is David Merrill of Polarion Software, and then from Mark Warren of Perforce Software. Among other things, what you'll hear from these two gentlemen are some real-world examples of why this technology actually does work and how a software-based solution can significantly increase your efficiency. So let me just tell you a little bit about the two speakers first. Okay, first it'll be David Merrill, who is a senior systems engineer for Polarion Software, and he works with customers globally. He's an expert in training for application lifecycle development best practices and product development and QA solutions. And just a word about Polarion. They are a leading provider of 100% browser-based and unified platform for requirements, quality, and application lifecycle management. The company helps global organizations in a wide range of industries, from automotive to medical device and aerospace, and they help them achieve agility, traceability, and compliance for their complex products. Okay, and then when David is done, you'll be hearing from Mark Warren of Perforce. He is a Solutions Director and Director of European Marketing at the company. Worldwide, the version management and code collaboration portfolio is used by thousands of customers, and that includes people like Salesforce, NVIDIA, Samsung, and Electronic Arts. With over 2 decades of experience in the software industry, Mark is more than qualified to be an expert. Okay, before I bring the first speaker, let me just go over some of the housekeeping stuff that you need to be aware of. The presentation will take about 45 minutes or so, and that'll give us a lot of time to answer your questions. You'll find a button in your console where you type in your questions. While the speakers are speaking, it'd be perfect if you could type in those questions, and then when we're done with the presentations, we'll answer as many as time permits. If we don't have enough time to answer all the questions, somebody will get back to you after the fact with an answer. If you have a question pertaining to the e-conference itself, like if the audio is not working or if the slides aren't advancing, put that into the questions, and somebody from the team will respond to that. There's a button there that says Enlarge Slides. If you click on that, obviously it'll take you into full screen mode. There's also a Forward to a Friend button if you'd like to email somebody about the event. And also note that in about 48 hours, the eCast will be posted online, and a podcast will also be available. Okay, that is enough for me. Let's get into the meat of this webinar. I would like to bring out David Merrill.
Thank you very much, Rich. It's a real pleasure for me to be able to represent Polarion to talk about what I'll consider not so much a question if continuous delivery practices are possible, but the challenge and really solving that challenge. That's part of what we want to do from within Polarion. And a little bit about my own experience, my own history. One of the things that I am energized very much with about Polarion is that we have such a key role in some of the companies doing cutting-edge product development. The very things that make the world's products and services work are the kinds of companies experimenting with bringing the continuous delivery of their product development process to market. Polarion was founded in 2004 with a disruptive vision to change the nature of requirements management and product development challenges to bring a unified browser-based system. And so we have been working for 10 years focusing on growing the customer base, learning from our customers, and being able to solve some of these challenges. Recently, in 2014, Siemens has made an investment in Polarion, and we're beginning to join the Siemens Teamcenter PLM tool to Polarian to expand the reach of application lifecycle development into and out of product lifecycle development and management. So as you can see, we're used by many of the Fortune companies that you're already aware of, and we have a very broad global user base, as well as a global presence of our company itself. And in addition to our own corporate locations, we have resellers worldwide and a very strong group of technology partners, one of which is certainly our fortune to be able to speak to you with today, Perforce. And so I'm very excited about these kinds of relationships that allow the traditional view of design and control processes to developing the product to be married directly with the development work of coding and branching and merging and delivery and building of the products themselves. So hopefully you'll be able to get a good vision on how we can accomplish that with these tools working together as a solution. What gets me up every morning isn't so much the definition of requirements management and what Polarian is as a tool, but I embrace what our customers do. So if I tried to explain requirements management to somebody, they might not really engage with what that can do. But I can say I'm curing epilepsy when I work at Polarian. I'm making sure that Marines are safe in flight in their helicopters as they move from landing zone to landing zone. I'm helping increase food and crop yields globally, and really even making sure that people with spinal cord injuries can get up and walk with bionic exoskeletons. Now, certainly David Merrill is not doing that, but I'm doing that as I participate and partner with our customers. So every single day, I'm meeting and speaking with those customers looking to build and solve the challenges associated with embedded software development. So I'd like to talk about 4 of these customer cases, not just to express how customers are using Polarian, but understand how embedded software development has such a diversified impact in the world today, even beyond the consideration of the Internet of Things. We have some very crucial devices, such as this, a non-pharmaceutical treatment for patients with epilepsy, where there's actually an electric cathode which attaches to what's called the vagus nerve, and through direct electrical stimulation of that nerve through an implanted device, which is controlled from an external software controller, patients can prevent and minimize the severity of epileptic seizures. And so for this customer, they're bringing a new change of life to their patients and their users. The second customer case I sort of alluded to earlier is a sensor system that maintains the health and updates the maintenance information associated to rotorcraft, helicopters that are used in the military, in commercial, and in meta-flight operations. So these sensors detect abnormal vibrations in the aircraft itself and send the data to collecting elements on the aircraft itself and send it to central databases where maintenance can be planned according to the vibrations and the information and heuristics of the tabulated data storage. And so they can not have to break down the aircraft at periodic intervals, but only manage the maintenance to the aircraft when needed. So it saves a tremendous amount of money and also allows the pilot to be warned if there's critical vibration issues in the rotor of the helicopter itself, to be able to land the helicopter before serious accident or injury. Now, one of the things about this customer who has to not just develop the system of its hardware and software combined together, but they actually have to comply with strict regulations. And these regulations exist for the Federal Aviation Administration in the United States and the Department of Defense. So it's not enough that they have continuous delivery of their software, but they have to make sure what they do deliver is absolutely compliant with these very strict standards. And one of the comments by the users is that using Polarian, they've been able to take their processes and their own standards for product development and make them certifiable. So when this audit takes place of being able to bring a new release or a new product to market, they're able to show the auditor that the project follows that certified process, and it makes that audit and that third-party certification very much easier. The third customer case is increasing crop yields, and I mentioned that as well, where a tractor is no longer just a vehicle, but the tractor is becoming a precision agricultural system, guided by GPS to make sure the same tire treads are taken every single time that help increase crop yields. Instead of just plowing and seeding and harvesting, the tractor is sensing soil moisture, and it's sensing the distribution of pesticides, and really allowing the tractor driver to become just an operator, and the farmer is becoming a producer. The steering wheel is largely replaced with a joystick, and dials and gauges are replaced with Android displays, with infotainment systems and heads-up information of the data being collected. The fourth and final customer case before I move on is a customer that manufactures unmanned aerial vehicles or drones. And one of the key messages here is that this aircraft is actually more like, as NASA puts it, a flying computer and less like an actual airplane. And it takes actually more people involved on the ground to fly this aircraft than it would take if the aircraft were staffed by humans in flight. And these strict development and operational standards also must comply with FAA obligations as they start to fly in the national airspace, as well as making sure that the work breakdown structure and the model development that they construe comply strictly with military standards. So I bridge that as an introduction to the idea that Polarian ALM is really a very flexible system that has to involve many different elements. It's not just about software development, but rather it's the inclusion of system requirements. It's the ability to manage test and quality management systems, to track and handle issue-based and defect management, to report on metrics and plan-based delivery, as well as newly introduced this year to be able to handle product line engineering and variant management at the informational object level of design, not just at the software, code, and file level. Well, in order to bring an embedded system to market, we have to look at more than just the software. And if at the center of this slide you see the kind of embedded software development you might expect to see in creating software and testing software, there are many different factors that impact. I have to analyze risk analysis and safety hazards associated with changes to the software that may in fact impact changes to the embedded device. I may have to interact with product line management systems where engineering change orders or very detailed hardware design is composed. I may also have safety and regulatory standards that are intrinsic to my own company or deal more specifically with manufacturing and distributing software to foreign locations. The rules to deliver a device in the U.S. can be slightly different than the rules to deliver in Europe or into the Mideast or into the Asia-Pacific theater. And all of these inputs into software development build a much greater ecosystem than merely software coding and testing. On top of that, of course, we have the business justification of requirements to manage marketing and sales requirements. and then the work breakdown structure of creating system requirements and functionality, and lower level design requirements which dictate the method in which this software will be created, so that the quality of the related developed software only increases with the use of a tool and a process and never decreases. So one of the messages that we learned from these customers is it's not just about the software anymore. It's a much broader base of impact into the developers doing their work. Now, this introduces another special challenge in software development, and that is the movement to agile-based development, or high iterations, which change frequently, of self-organized teams trying to make the gap up between the description of a requirement and what is best to be implemented in the software. Now, in an embedded system, we might want to bring the best of agile development practices together with a formal V-model or waterfall approach, which is usually intrinsic to the notion of hardware and product design, and certainly a factor in the kind of regulatory compliance that's needed in aerospace devices, in medical devices, and in automotive devices. And some of our customers actually might start out thinking very agilely and not worrying too much about the V-model plan and regulatory compliance, because they manufacture a handheld computer that people use to play games on. Well, as soon as that handheld tablet is now also prescribing dosages of medication, or is managing the controller for an embedded medical device, now the practices of that operating system development and the applications that that device manages have impact into the same safety and regulatory standards that these mechatronic and medical devices themselves have. So we have to merge these two to get the best of both worlds. And so many of our customers have dubbed Water Scrumfall as that combination between the formal or traditional V-model development practices with the introduction of agile epics and user stories, which introduce a implementation of that V-model process. So iterations with software become faster. I don't have to wait 6 months for my testing. I can incorporate the best standards of Agile manifestos, and using a tool like Polarian, using Polarian for this Agile development also lets me break down the physical barriers of a Scrum team or a Kanban team that can include global involvement. And oftentimes, the work that's done underneath this line of the V model represents that Agile development practice. So how does Polarian help differentiate and bring this kind of practice to embedded software? Well, the first is that we want to make sure that when we plan builds and releases in Polarian, that we're able to have this unified ALM solution reach out and tap those software products which hold the best of breed technology for things like software configuration management, or shall I say, file versioning. And so we have a connector from Perforce, and that connector for Perforce builds links between what's going on in Polarian with the versions and commits done to a Perforce depot. And that's going to allow us to tap into the development operation of deployment and deliver part of this product development process in a continuous delivery mode. Along the line, Polarian, of course, is a certified tool for using with ISO regulatory requirements such as 26262 for the automotive environment, or IEC 61508 for manufacturing, and other templates exist for FAA-based regulations and automotive SPICE. It's been certified by TÜV Nord as a trusted tool. Now, one of the challenges that we would handle is being able to introduce the inclusion of external data from your sources, either through regulatory compliance issues, through downloading the best practices of engineering standards, and being able to bring data that you already have in document format or other data stores. So Polarian allows you to easily import and organize information coming from Microsoft Word, from Excel, from Project, and other sources. It embraces a RecIF method of being able to dictate and itemize large quantities of data between requirements management tools. And once in Polarian, we have a high degree of management of that information, but still retain the very beneficial document structures that we've come to appreciate in developing products. However, additionally to that document round trip ability and exchanging information back and forth to our stakeholders, we can bring automated planning and tracking to the tool. So as requirements are completed, as issues are being resolved and code is being committed to Perforce depots, I'll be able to demonstrate the completeness of entire product line deliveries as well as smaller Agile-based Scrum iterations. So a sprint would be represented as an automated plan within Polarian, and many sprints together may help deliver a component release. And that component release would be able to ensure that the product is developed on time. Again, instead of waiting 6 months or 12 months or 18 months for final results, we'll see and feed the incremental value of the completion of that project throughout its design and implementation process. But as I mentioned before, requirements and development is not enough. We have to be able to introduce risk management items and data into the development process. So being able to manage an FMEA or failure mode effect analysis worksheet, instead of having that be separated from the design process, we introduce that as a full citizenship, with full citizenship to the same artifacts which describe the product itself. And we can build automated verification and validation processes. This becomes very important for those tests and verification that happen in an automated fashion associated to continuous delivery builds and unit testing, but also combine some of the higher level items of system integration tests and release testing and ongoing manual tests that might go in concert with those automated tests. Polarian provides us a vehicle to bring all of that information into one central source of truth where validation and certification can be proved. And that helps us reach even further to regulatory compliance. Again, instead of keeping these items in individual silos outside of the information of product development and design, we will include these items as legitimate work items that relate through traceability to our design tasks, so that automotive companies that are defining a potential hazard to a vehicle will be able to show mitigation of that hazard through the design and functional safety architecture built into Polarian for specifically ISO 26262 compliance. And that's how Polarian project frameworks can be certified with the level of compliance needed to show to a vendor chain and to regulators to prove the methods of delivery. And so not just automotive, of course, but medical and individual ISO standards might exist in different types of product lines: toys, food production, pharmaceuticals. And each of these domains can be introduced into Polarian as key documents and work items. We also are introducing, of course, a new report method to quickly create drag and drop reports and notifications to our stakeholders. And we're going to be able to introduce the idea of product line engineering so that features and variants can combine the common nature of component design with the variability needs of mass customization to deliver the product in more formats and with more options in more markets faster and faster as well. And then finally, key to us and a perfect launch point to introduce my colleague Mark Warren is being able to, at a very granular level, integrate the data in Polarion with development activities taking place in Perforce repositories. The code and the actual events done in Perforce become direct and traceable links to the Polarion data structures. Live branches in Polarion can be correlated with branches of development, whether new development, parallel or maintenance development activities, to bring the multiple storage methods of software configuration management into, with that same level of citizenship and hierarchy, the remainder of the product development structure. So I thank you very much for your time, and with that, I will transfer to my colleague Mark Warren from Perforce.
Thank you very much, David. I just want to jump in real quick before Mark comes out and remind the audience to type in your questions into the console, and then when Mark is done, we'll answer as many as we have time for. Thank you very much. Okay, Mark, take it away.
Okay, thanks very much, Rich. Appreciate that. Thanks, David. Great overview and introduction there. I'm going to be pretty quick here. I want to make sure we've got time to cover those questions, so please do submit them. Just a few words to start off with to introduce Perforce to those of you that haven't encountered us before. We are, at our core, version management specialists. We're a privately held company, and we've been around now for the best part of 20 years, headquartered in California, but with offices and a network of partners around the globe. And because of our special architecture and the way we've been built, we are depended upon for managing the development of a wide variety of different kind of asset types. Probably the best way of demonstrating that is to think about major industry segments. And if you think about chip manufacturers or gaming or cloud services, mobile devices, healthcare or automotive, think about some of the leading brands in those different marketplaces, and they all depend upon Perforce. So whether they are Samsung Mobile, building every mobile device, both the hardware, the firmware, the operating system, the applications, all versioned and managed through Perforce, to people like NVIDIA and Intel. And I'll talk a little bit more about some of those customer stories as we go through this, as examples of how they depend on their version management platform to deliver on their continuous delivery pipeline. But I'm going to step back just a little bit and talk about the challenges that embedded systems builders are facing and why they're considering this move and why they are actively moving towards continuous delivery. It's almost becoming a cliche these days to talk about every product is a software product. Even if you're building a car, a truck, some kind of health device, although there is a physical product, usually the thing that makes the product successful or that differentiates one product from another is the software that's running on it. These days there are more lines of source code running in a modern automobile than there is in a fighter jet or an A380 Airbus. Think about healthcare devices. Maybe you're wearing, like I am, a pedometer that keeps track of how much or how little exercise I do. That's quite a simple physical device, but it's got quite complicated communications requirements that communicates through Wi-Fi or Bluetooth to some cloud-based server, which is aggregating a lot of data and doing some crunching on that big data, and then feeding back reports on how active or inactive I've been. It might include recommendations for what I should do to add more exercise into my daily life. It might even include things like video and training videos. So, there's a lot of different kinds of assets involved in delivering that entire product, not just the physical band that's strapped to my wrist. And the same is true in all of these different industries. And because there are so many different elements in a product, there are many different kinds of contributors. There may well be software coders, people doing the JavaScript, the C++, the assembler code, whatever they're building. But you've also got designers. You've got product designers. You've got chip designers. You've got people building video and images. You've got people building documentation to go with the product or completing compliancy documentation. And you've got product managers and project managers that are keeping the whole thing actually on track and being delivered. And these products having to be delivered much more frequently. Just a few of the most obvious reasons for that. Customer expectations have changed dramatically, particularly in the last few years, particularly since perhaps the introduction of the iPhone. Expectations of consumers is that products will get updated more frequently. People don't buy one radio and expect that they're going to keep that for the next 25 years. They expect that the radio will be able to pick up new services as they become available, especially these days of DAB or Sirius FM, or more likely these days, internet radio. You shouldn't have to upgrade the hardware just to get a new radio service. Customers expect to be able to manage the releases onto their devices. So how can you meet that customer demand? Because if you can't meet that demand, then your competitors will. So there's this always competition is your driver. Can you stay ahead of your competition? If you've been successful in a market for a period of time, almost certainly there will be a startup that doesn't carry a lot of your legacy and your baggage that can react more nimbly. Can you, as an established player, be able to react as well when those market requirements change or when customer expectations change? Of course, the key to success for any successful commercial organization is how you manage your margins, and that means primarily managing your costs. How can you deliver additional functionality and react to customer demand while still managing your costs? You can't have huge releases that take a lot of investment, release them into the marketplace and find you've actually missed the target. You haven't met those customer expectations. You've consumed a lot of investment, you've built up a lot of cost, but you're not going to see the benefits of that as you go to market. And finally, as frequently happens in embedded systems, as David mentioned earlier on, you have compliancy requirements, whether that is something like ISO 26262 for automotive, or healthcare requirements, or defense requirements. You have to maintain your compliancy. Now, trying to react to change more quickly can't allow you to do that at the cost of maintaining compliance. Otherwise, you won't be able to sell your product in the marketplace. So these are just some of the leading requirements that people talk about as that's driving them to be able to deliver their products more frequently, and that's embedded systems, physical products, as well as software products. In a way, you can think of this as an evolution of what's been going on in the software industry for the best part of 20 years now. The move from this waterfall, as David was describing, from waterfall to agile in software is pretty much complete now. And increasingly, we're seeing software developers move from agile to continuous. Can we see the same progression for people building combined software and hardware products? Well, I think we can. This quote here from Kurt Bittner at Forrester, where you can no longer expect to have product release cycles of 12 to 18 months. The same is true for physical products as well, I would suggest. So how can you get there? Well, if we look at how continuous delivery has been adopted in more pure software environments, and various lessons have been learned. Some of the key ones will be, it's about being able to continuously have the option of releasing a product to your customers as early as possible. And that requires a number of things. One is actually managing what goes into the payload for your releases. So you don't want to do big bang releases with hundreds of features. You want to do small chunks of release with only one or two features at a time. So that reduces scope but reduces risk and makes frequent releases much more achievable. Potentially, every time you make a change, you should be able to release. Now, that's quite difficult with a physical system, but it's the idea of being continuously releasable, even if the business isn't ready to release yet. Another key element of a continuous delivery pipeline is about feedback. You've got to be able to get your changes to either your test systems or to ultimately your customer get feedback, and then be able to react on that feedback. That could be coming back to your requirements backlog and reprioritizing your requirements so they can remain flexible and relevant to your customers and to your market. Or maybe just into development, saying, actually, there are bugs that need to be fixed, or there's ways that we need to optimize the design to make it easier to produce later. It's about having fast feedback and, importantly, reacting to and making changes in response to that feedback. And that feedback may well be managed through a tool like Polarion. As I say, releases may not be to the customer because, when you're making a physical product, there will be prototypes required, there will be tooling to be set up. But if you look from your development process, it might be treating the test team or the QA team as your customer. How frequently can you release to them? Now, they may not pick up every build you can deliver, but at least they have the option to do so. One of the key elements to make that possible is automation. If you rely on human beings to do your builds, to verify the builds before they get handed into some kind of formal QA or formal prototyping, you will have a bottleneck. You're also introducing potential error. Unfortunately, human beings are not great at that repetitive kind of task, but automation is really good. So automate as much as you possibly can. And as I say, it's all about potentially considering every change that you make, how quickly can you get that into a potentially releasable build. Now, that's not trivial, even if it's just a pure software project. But if you think about your embedded systems, think about all the different elements that go into making your product. What I'm trying to warn you against here is just thinking about the software or just thinking about the hardware design. Think about all of the elements that have to come together to create that product. Certainly, there are hardware designs, there may be chip designs, there may be firmware. You may be bringing in components that one of your suppliers sends to you. You've probably got some documentation that needs to be kept up to date and released with the product. You may have internal documentation to show that you've been through your processes. You may have compliance documentation that has to be submitted to regulatory authorities. Ultimately, you're going to have something that needs to be sent to a production line that includes instructions on how to build a product and also some software that's going to be loaded onto the product before it goes out of the door. Think about where all of those bits of information are stored and who's creating them. As I said before, you've got coders that are working on source code, and they may be using version management tools like Perforce, or maybe they're using Git. And Git is a pretty good software configuration tool or software version management tool, but it's not so great at managing the built components, or they're not so good at managing large binary objects. You may be using tools like MATLAB or LabVIEW, and you're talking about virtual hardware definitions or test scripts that need to be managed. You may have artists building nice graphics to go onto your website or onto the mobile app that goes along with your device. They're using tools like Photoshop or Maya 3D, and they'll be working in their own silo. They'll be putting their files and their outputs onto some kind of maybe file share. You might have people working on documentation, either internal or end-user documentation, and they may be sharing via a file-sharing service like Box or Dropbox. And then you may have these project managers or people trying to keep the whole project in line, and they may well be using email for their collaboration. And somewhere in your business, you've got somebody with a title like a release manager, a production engineer, or a DevOps engineer that's trying to work out how to find the right revisions of all of these bits, put them into one place that they can actually be rolled out into production. Think about how many places that person has to go to find the right set of bits. The more places they have to go, the more variation of those kind of repositories, the harder it is to ensure that you've got a consistent set of bits to release into production. Think also about how difficult that makes it to reuse components. If you're building a new product, how many places do you have to go to pick up all of those pieces? Now, Perforce, we think there's a better way. And because of this architecture of Perforce and our new Helix platform, we can provide a single repository that all of these contributors can use as their source of truth, their repository where they put their work items. The DevOps engineer, the release manager, can go to one place and get the right set of bits in one easy place. And then you've actually got this whole new role, new set of people in your business that probably need to know about this as well. The CSO, the Chief Security Officer, or you may have a Chief risk officer, somebody that's responsible for ensuring that the assets of your business are properly protected. Now, these software assets, these design assets, are your company's intellectual property. They need to be protected. Oftentimes, these CSOs and people with that kind of responsibility have no idea where all of these bits are. So how can they know if they're being protected? One of the things you can do with the Helix platform, now that you have this common repository, is to watch what's going on to that repository and start to spot if anomalous behavior is happening. Is somebody taking files from projects they don't normally work on? Are they taking a lot of files and putting them onto removable media? All of these are potential signs of your intellectual property being stolen. And that's something that's possible with the Helix platform. We don't have enough time to go into all of that detail right now, but please come along and visit perforce.com and find out more about that. Before I wrap up, I just want to go over a couple of customer stories and talk about how some leading embedded systems manufacturers are relying on Perforce today. You're probably all familiar with NVIDIA. They're famous for their graphics processors, for their motherboards. These days, they've got a whole realm of industries they're working on in terms of medical simulations, and these days they're building systems for the virtual in-car dashboards, and they've got some really nice software tools for designing those dashboards. They've been using Perforce for a long time now. They manage their hardware and their software in Perforce, but they realize that actually to get these products out relies on all sorts of contributors from across the business. So around 90% of all NVIDIA employees have a Perforce license. That means that people in sales and marketing and legal are using Perforce as well. Their repository is something over 300 terabytes of data these days, with over 500 million files being managed. And that's absolutely fine. Perforce can scale very easily to that kind of project. We equally handle 1- and 2-person projects just as easily, all with the same product, all with the same ease of admin. What I wanted to pull out of this story is really that they have understood all of the different contributors that are required to make a successful product. Last year, we did another webinar with Polarian and also one of our customers, Scania. You may know Scania for the trucks and buses that they build. They're very leading edge in adopting agile and lean processes in their development processes. I recommend, if you get the chance, go look on the OSM website, come and visit perforce.com and search for the recording of that webinar, and you'll hear Lennart Kjolin from Scania go into much more detail about how they're adopting lean methods in their production of these vehicles. I haven't got enough time to go into the details right now, but these are some of his charts. And the thing I wanted to point out here is, although the overall life cycle looks a lot like waterfall, a lot of what goes on inside the development processes is very much agile and lean. And what makes that possible is that they have a common version control platform for all of these contributors. And they happen to use Perforce also for their artifact repository. So again, they've got one place, they do a build once, and they've got one place to go to get the single source of truth, to get the assets that can be rolled out through their release pipelines. And these are some of the lessons learned. I'm not going to go through every one of these bullets. You will get a link to the recording of this session later, so I recommend you go back and take a look at these recommendations. I've got a summary of those myself, but it's well worth spending a bit of time taking that list. So in summary, the question we posed at the beginning of this webinar was, are continuous delivery practices possible when developing embedded systems? My answer is yes, it is possible, and yes, it is becoming a requirement. So you do need to be planning for this if you haven't started so already. How you get there? My recommendations are, take a look at your existing tools and processes. Are they fit for purpose? I know, talking to many of our customers, that they are using a mixture of development tools and mixture of different repositories, either because they have these different contributors, and I've gone over that problem already, but they may also be using tools they've inherited through acquisition or just historical reasons. I recommend consolidating and simplifying your tool chains as much as possible. I've already talked about the need to automate. Again, having a common single repository makes it much easier to automate. And don't forget to version your automation systems along with everything else. I can't reiterate enough, that version everything is the starting point for a lot of success. And you need that single source of truth. And I haven't got time to go into all of this in detail now, but please do visit perforce.com to get more information. So at that point, I'm going to hand it back to Rich, and we'll handle your questions.
Thank you very much, Mark. That was excellent. I'd like to stay with you, though, and I'd like to go back to your reference to NVIDIA. My my question to you, I'm looking at this slide, and we have to be talking about a huge amount of code here. If, for example, they were not to go with this this type of solution, what would the alternative be? How would they get this job done otherwise?
In their words, it wouldn't happen. They started real simple back in, was it 98, 99? They had a real simple chip. They only had 4 variants of their product, and they could kind of manage it at that time. Today, they have billions of GPUs potentially on a card today, and they can only do that because they have this version management platform to manage all of these different components. There's a very nice video, very kindly they did for us on our website, perforce.com. It only takes a couple of minutes. Do take a look at that. The quote I've got on the slide there I showed earlier was, if it isn't in Perforce, it's not in the product. They absolutely live by that, and you know, they believe in it so much that that's a mantra they've rolled out across the entire business. If they didn't have that, you know, to answer your question, they really wouldn't have been able to grow and scale in the way that they have. So it's a kind of chicken and egg thing. Could they grow without Perforce? No, is the simple answer.
Okay, that's a great answer, and it's also a great endorsement. Okay, now I'm...
Thank you. Yeah, it is.
That's fine. I'd like to go back to David now, and I'd like to make sure that we're all on the same page with what he was talking about with Agile. When you were talking about Agile, David, you're assuming that it's mainstream in, well, I'm using my own words, but it's mainstream to every developer. How much penetration is there with Agile? I mean, is this something that everybody is either aware of or is using, and what percentage are actually using?
I think that's a really good question, Rich. First off, maybe just a quick synopsis of Agile. In the early 2001, several software engineering managers got together and they said, instead of following and being married to complex processes, contract negotiations, and strictly following plans, we're going to innovate so that individuals and interactions become more important, and quickly creating working software has priority over those things. And the net result from this team turned out to be some very formal practices. One is called Scrum, like an Australian football or a rugby scrum, as they kind of go getting to pick up the ball. That Scrum greatly shortens the iteration of development work and breaks down the amount of work from high or low-level design requirements to something that's often called user stories. And instead of estimating the stories to be a number of hours to fulfill, they take a look at that Scrum and give those stories story points. And they start working in 2-week, sometimes 4-week, but usually somewhere between 1 to 3 week intervals, where the teams rapidly create, develop, and test software. And at the end of that process, they come back and evaluate it. So is it pervasive in the environment? Certainly, if you talk to a conventional software company, they are seeing this for sure. As Mark mentioned with Scania, a mutual customer, I mentioned quantum technologies, and we had a quote from one of our customers who, in the U.S., has principally architected a configuration of agile software development married with formal waterfall and V-model development. And so it takes the idea of putting the plan-based regulatory side of formal hardware development concerns together with the flexibility that software teams iterate and make changes at a much greater frequency. And the cost of building software continuously, once you have a system established, as we've been discussing, is virtually free to be able to build software, automatically test software, and see that it's delivered into test prototypes. That's certainly not the case for developing the hardware elements themselves. And so that's the combination of the two, that the software teams just simply have more freedom to test and manage and show their software without having to wait for elongated development practices that happen to be set by hardware or mechanical and electrical engineering teams.
Okay, very good. And then just like to clarify one thing while you were speaking, somebody asked about the duration of the sprints. I think you mentioned that, but let's just make sure that we answer every question. What is the duration of the sprints?
There is no such thing as a static duration of a sprint. The idea behind Agile is that the teams are self-organizing. So a team could get together and say, we want to sprint at a cadence of 1 week. Another team in the same company could sprint at a different cadence. However, if I took kind of a cross-section of most and even include Polarian ourselves, we are an Agile software development organization. Our sprints are of a 2-week length for all the teams. And so I would say as a rule, that's the most frequently occurring that I encounter.
Okay, very good. Okay, I'm going to give you a little break, David. Let me ask Mark the next question. Isn't version management suitable only for the software? What about the hardware?
Yeah, well, traditionally that's where kind of version management has come from, and some tools were built assuming that they're only managing source code, and for people that aren't software developers, source code is usually quite small text files that are usually edited in some kind of text editor, so whether that's C++ source code or Java or Assembler, and you know, that's pretty straightforward. Perforce was always built assuming that you're going to manage any kind of digital asset. So these days you may have a model-driven development where you've got some kind of model file types like a kind of sort of database. You may be using quite large virtual hardware definitions in XML. So there's all sorts of different file types, and obviously, as I said before, these modern applications include images and video, whatever. So you've got JPEGs and MP4 files and what have you. So these are very large binary files. But Perforce was built to handle those kind of large files. So we scale very easily to handle them. And, as an extreme example, one of our customers is actually Pixar Animation. So every frame of every movie that they make is versioned inside Perforce. So it gives you an idea of the kind of flexibility that we have to handle all kinds of digital content. And these days, it could really be anything from software to the built executables, so linkable libraries, DLLs, or even CD images, ISO formats, or Docker images are being stored inside Perforce. So yes, traditionally version management has come from the software engineering background, and traditional tools can't handle the kind of assets that modern applications need. But that's exactly what Perforce was built to manage.
Very good. Thank you. Okay, next question. This is for David. How does IV&V fit into the process?
So Rich, that's a very important and loaded question. Let me first break down that term, IV&V. That generally refers to independent verification and validation. And this can happen in many ways with Polarian. We've already talked about at the software code level, I might be doing continuous build events, and I'll have integrated unit testing automated during the delivery of the software. And so the first part of verification in this is to make sure that information is available. Verification is often the quantifiable proof that I've implemented a feature or have a particular component, a low or high-level requirement that does exactly what I say it should do. And that can be a manufacturing verification. It could be a usage verification. It could be a UI, or it could be this information from the automated build event. Well, now if I combine that with higher level proof points of validation, I have an obligation when I release a regulated product to be able to either self-validate and verify or introduce an independent source, a consultant or a different quality group within my company, not responsible for the development process, to now perform top-level validation of that product. And so inside Polarian, that same validation for the process on how the product was developed, the process on how the continuous delivery was managed, the process of how the different products were manufactured can become, in Polarian, objects and work items and test protocols, and these test protocols are executed, and as I execute them, I'm recording the electronic signature of all the people who are establishing those proof points. And at the end, I end up with a body of evidence, objective evidence that it's often referred to, that I can show to an auditor, to a legal organization, or to a third-party consultant or consulting group to demonstrate the type of processes so that they can complete their own verification and validation. So in many cases, that happens in and through Polarian for both the process happening in Polarian and the intended use of those process adaptations so that products can be credited and certified to those independent organizations.
Excellent. Very good. Okay, we have a few more minutes left. If you still have more questions, please type them in. Like I said, if we don't have time to answer them all, somebody will get back to you after the fact with an answer. Okay, Mark, your turn. I think this one looks like it's for you. The question is, do you have a recommendation on where to start with adopting continuous delivery? Mark, you're still with us there. Okay, we may
I'm sorry,
have
I'm talking
lost
myself on mute. I'll try again.
There you go. Yes, please
Hello.
try again.
Yeah, it's okay, Rich. I'm back. Yep. Sorry, I was on mute. Yeah, great. It's a really tough question to answer simply, and we haven't got very much time here. A couple of things I'd recommend is to start with considering. First is think about the process that you have. It's not just about the tooling, but what is the process? A technique that people often use when looking at software is how quickly could you get a zero change out? So that is to say, if you change not a single line of code, what is the process to get from a developer desktop to a customer's hand? And if you look at that, you can start to see where the bottlenecks in the process are. It might be that it takes a day to get built. It might be that it takes 3 weeks to get through testing. It might be it takes a month to get through prototyping. And then you can start saying, well, okay, which parts of that process can I actually work on, can I optimize? And that will give you some idea of where you need to start your move towards continuous delivery. A second thing that's worth looking at is starting small and trying to accelerate the pieces that you can, and where possible, perhaps the thing to do there is automate as much as possible. So do you have a lot of manual processes trying to pull together all of the elements of a delivery before you can actually do a build and hand over to testing? So that will give you an insight into how many different repositories, how many different silos of information you have to go to, and look at each one of those and say, can I consolidate this down and get this to as few points of record as possible? Maybe ideally get to a single repository, as I was talking about earlier, and then that will drive the conversation into, okay, do I have the tooling to support that kind of single repository, to support the kind of automation that I need to build out the rest of my process? So, start with reviewing the processes, look at the different sources of information, review your tools and processes, and then you can start to work out a plan to, okay, that's where I am, where do I want to get to? And part of that conversation might well get into some really hairy topics about cultural change. Are your developers and engineers ready to accept this kind of pace of delivery? Can they accept feedback into their planning process at the kind of rate that they're going to get it now? And that might take longer, but try and get those quick wins in understanding where your process is today and where you can get quick wins out of optimizing the process, and start that road. Don't be frightened by the fact that it might take you a long time, and you may never finish. It's one of those continual improvement things, but you can start with that small step and get you on the road.
On the road. That's where we want to be, on the road. Okay, yeah. I'm afraid that's all we have time for. The hour does go very quickly. So I would like to thank both David and Mark for their great presentations, and I'd also like to thank Polarian and Perforce for sponsoring this event. And of course, we could never do this without you, the engineer, who's out in the audience. So Thank you all very much, and have a great day.